हेलो एवरीवन वेलकम टू माय चैनल। सो आज हम बात करेंगे डिफरेंट टाइप्स ऑफ ट्री अवेलेबल फॉर द डेटा स्ट्रक्चर, राइट? सो वी आर गोइंग टू टॉक अबाउट डिफरेंट टाइप्स ऑफ trees. So we'll be starting with the first kind of tree, that is general tree. This is very basic tree and you are not going to use this tree probably anywhere, but let me tell you what is the general tree. General tree is a kind of tree where you can have any number of children and there is no restriction over the number of child a parent can have, right? So if this is the root, you can have any number of children, right? So I'm assuming it is having four number of children, right? Now here this child, this parent is having like say five number of children and likewise. So what is general tree? It is a tree. It is a tree with any number of children. There is no restriction over the number of child. We are probably not going to use this tree, so I'm not going to go in further with this, right? This is very basic tree. Now binary tree is important term. So what is binary tree? So basically tree is divided based on, mostly based on the number of child it is having. So binary tree, as the name suggests, bi means two, that means every node can have at most two children. So every node of this tree can have at most two children, राइट? तो उसमें क्या होता है कि हर एक नोड के आइदर जीरो चाइल्ड होता है या वन चाइल्ड होता है और टू चिल्ड्रन होते हैं। टू से ज्यादा चिल्ड्रन पॉसिबल नहीं है। तो लेट मी शो यू सम एग्जांपल्स। आपको आइडेंटिफाई करना है कि इसमें से बाइनरी ट्री कौन सा है। आई एम नॉट यूजिंग लेबल्ड ट्री, राइट? मैंने यहाँ पे नोड की कोई लेबल नहीं दिए है, लेकिन आप लेबल दे भी सकते हो। आई जस्ट वॉन्ट टू शो यू द फॉर्मा so that you can understand, right? So you have to decide which of the following is the binary tree, right? So let me draw. D is something like this. Let me write it in uppercase. So this tree, right? Let me draw another tree like this. You can draw any type of tree, right? Now let me just count. So here every node, let me count the number of nodes in every at every node. So here two child, here two child, here two child, and these are the leaf nodes with zero children, right? Zero child is there. So this is definitely the binary tree. Let me just highlight it with a different color. So I'm just going to highlight it. This is the binary tree. Now let me just decide for the rest of the trees. So here number of children is 3, here 0, here 0, here 0, here 0, here 2. You know that you cannot have 3 children in binary tree. At max you can have 2 children, right? Or 1 or 0, but not more than 2 or not less than 0, right? So this is definitely not a binary tree. Now let us assume for this is 2, this is 2, this is 0, 0, 0. This is definitely a binary tree. Now what about E, or sorry, D? Here this is having one child, this is having one child, this is having one child, this is having zero child. That means it is a binary tree. And here also this is having one child, this is having one child, this is having one child, and this is having zero child. So this is also a binary tree. So among all of these trees, this one is not a binary tree because it is having more than three children, right? So this is about the binary tree. We are going to go in detail with the binary trees with its properties as well. So don't worry, I'm not going to go. I'm just going to go in deeper in this video, but I'm going to make a separate video for it. So stay tuned. Now, what about the K trees? So in K trees, what we are going to do is, suppose we are having K child, right? Ternary tree means we are having three child. Four tree means we are having four child, at max four child. So here in K tree, we are having at max four children, sorry, k children. For hereditary it is 4, for ternary tree it is 3, and likewise. So we are having k at max k children, and at mean 0 child. Right. So let me just draw k hereditary. So here you can decide at max for 3 hereditaries or ternary trees, you may have at max say uh, 3 children, right? So this is k hereditary, 3 hereditary, this is 4 hereditary. How can you draw it? 0, like the root node, and this. So this is 4 hereditary, right? So this is the general term of, like, say, binary tree, ternary tree, and likewise. Basically, it is defined based on the number of nodes. Now, what about the balanced tree or balanced binary tree? You can see this binary over here. That means it must be a binary tree, but it should be a balanced. How? Binary tree means it must have, there are two condition. One is it must have at max 2 children. And second condition, this both condition are ended actually. This both conditions should be satisfied in order to make a tree, a balanced binary tree, a difference between the height of left subtree and right subtree at each node must not exceeds must not be greater than 1. Right? Now what they want to say, let me draw the example. Right? So here we are having a tree like this. Right, we are having a tree like this. Now we have to find the difference of left subtree and right subtree for each node, and we have to write it over here. So let me show, this is the leaf node. So for here there is no left subtree, no right subtree, so difference is 0. Same for all the leaf nodes. Now what about this internal node? For this internal node, left subtree is having height, say 1, right subtree is having also height 1, that means it is difference is 0. So let me write the difference only. So I'm just writing a difference 0. Right, I hope you are getting my point over here. So here difference is 0. Here for left subtree there is null, so height is 0. For right subtree it is 1. So here difference is -1, which is less than 1. So it is okay. Right. Actually here it should be mod 1 or mod, like, say, height must be the difference. This should be a mod. I have put mod at the wrong side, but it should be a mod, right? So here difference is 1, right? Now here you can see this is left subtree is having height 2 and right subtree is having height 2, so the difference is 0. Here the for this node, let me show you, this node is having no left tree, no right tree, so height is 0 as well. I have already written it over here. Now let us decide for the root. So for root, the left subtree is having height 3 and the right subtree is having height 0. That means the difference is 0 over here. That means it is not balanced, right? So this is not the balanced binary tree. I hope you guys are getting it. So this is the example of unbalanced binary tree. Now let me show you how a balanced binary tree look alike. Right. So let me just show you using a different pen. Let me just draw the tree like this. Right. So for this tree, let me find the height difference of each at each node for each subtree. So here it is 1 minus 0, that means 1. Here it is 2 minus 1 because this is having height 1. So that is 1. Here it is 4, say 1 minus 0, so 1, and here it is actually 3 minus 2, that means 1, right? So this tree is having all the nodes which are having height difference between left subtree and right subtree, and not more than 1. That means this is the best example of balanced binary tree. Now, if I'm writing or drawing something like this is not the balanced binary tree. Why? Because it is not the binary tree. Here, these are the three children of a root, which is not acceptable as a binary tree. So this is not the example of balanced binary tree. So make sure that before proceeding, you just see if these two conditions are satisfied simultaneously or not. This is all about the balanced binary tree. We are going to talk about ABL tree, red break tree, all in detail in the further videos. So stay tuned with me. And now, what is pathological tree? So pathological tree is the tree which is having only one, in which each internal node is having one child. Each internal node is having one child one child, either left or right. So here, let me just draw something for you. This is the quick tree, right? Here, in this every internal node is having one child. This is having one child. This is having one child. This, right? And leaf node is at 0, obviously. So this is like, say, having right child, and this is left. It should have either right or left, not both. So this is not example of pathological tree. In pathological tree, you are having only one child. Each internal node is having one child, either left or right. This is also the classic example of pathological tree because it is having only the right child. So, right. Now the last tree is all about skewed binary tree or skewed tree. Here I have taken example of binary tree only. So you can say it is pathological binary tree, right? We are going to study more types of binary trees as well, like full binary tree, complete binary tree, right? So pathological tree you can just assume like this also. Now, what about the skew binary tree? It is a kind of pathological binary tree in which either we are having left child only at each node or right child, right? This is a classic example of skew binary tree. Here we are having one child at each node, internal node, and one child at each internal node, and uh, leaf is having zero child, right? As you can see over here. And it is like, say, you can say it is right bias, then it is left bias because it is having only right child and it is left child. So this is right skewed tree, and this one is left skewed tree. Right. So this is all about the different types of tree. Now in the next video, I'm going to talk about different types of binary trees available. So stay tuned. Thank you so much.